Alright, welcome Algebra 1 students to another video. This is going to be lesson 9.5 and we're going to be talking about the quadratic formula. And this formula, I know it looks very complicated. If you guys look at what you see here, it might look very scary, but I'm just letting you know it is a very useful formula. You're going to see this again many times, especially in Algebra 2. And this is one of the methods we use to solve quadratics as well. So let's go ahead and just dive right into it. Before we get into the quadratic formula, I want you guys to try to do something and try to solve this following equation. Let's say we had x squared minus 5x plus 3, and it's equal to 0. We learned back in chapter 7 how to solve polynomials like this. For example, I know that this has 3 terms, so you should be using the Xbox method. So go ahead and try it out and see if you could do it using the Xbox method. Alright, so if you tried it out, you should have noticed that there was a problem. If I do my Xbox method, for example, I'm going to draw my box. I'm going to draw my x. The x squared we put on the top left, the 3 put on bottom right, the negative 5x goes at the bottom, and then multiply the x squared and the 3 to get 3x squared at the top. Notice that no matter how hard you try, we're not able to figure out what these sides will be. They actually end up not working. So we get kind of stuck here. We're not able to solve this using the Xbox method. So that means there must be another method to kind of figure out what the solutions are. And that's where the quadratic formula comes in. The Xbox method, it only works for some quadratics, but the quadratic formula, it's very nice. It works for all quadratic equations. So it's like the jack of all trades. It really helps you just solve any kind of quadratic that you'll encounter. So that's why it's very useful. But again, it might look a little intimidating. So let's kind of go through that. So again, the quadratic formula, it's the formula we use to solve any quadratic equation, literally anything. That's why it's really nice. And again, the quadratic formula, the first thing we need to do in order to use it is we need to make sure that our equation is in this form right here. And hopefully that form looks familiar. This was called your standard form. We should have learned this back in chapter 8. So we need to make sure that the quadratic is in standard form first, because notice that we're going to be using our a, b, and our c to kind of plug into our quadratic formula. So once our quadratic is in standard form, we're going to use this formula right here. X is equal to negative b plus minus square root of b squared minus 4ac all over 2a. And again, we need to know what the a, b, and c are, because you could see that they show up here in our quadratic formula. So again, very, very important. You really got to make sure that your quadratic is in standard form first. So just make sure everything is on one side, the other side is equal to 0, and that's when you should use your quadratic formula. This is super duper important. A lot of students always forget to put it in standard form first, and they get some really wacky answers. So just make sure it's in standard form. Secondly, if a term is missing, for example, let's say instead of ax squared plus bx plus c, let's say you had something like ax squared plus c, right? Notice that your bx is missing. Then just pretend that your b is equal to 0 in this example, right? So anytime there's a term missing, just pretend it's a 0. Another thing is, let's say you had like ax squared plus bx, right? And the c was missing, then just pretend that your c is equal to 0. So anytime a term is missing, we'll just use 0 as it's kind of like a placeholder for that number. With that said, let's go ahead and try an example. Let's say we had this equation right here, 2x squared minus 5x plus 3 is equal to 0. Again, first thing I want to do, make sure it is in standard form, and I could clearly see that this is in standard form. What I usually like to do, I like to write the standard form above or below it, just so I could see what the a, b, and c are. So we could see that our a is equal to 2. We know our b is equal to negative 5. And we know our c is equal to 3. So once I know those things, all I'm going to do is just plug those into my quadratic formula, which is this big thing right here. So anytime I see an A, I'll put in 2. Anytime I see a B, -5, and C, 3. So let's try it out. We have x is equal to negative b. So we have negative. Our b is -5, so notice it's going to be a double negative here. So we're going to have negative b, -5, plus minus the square root of b squared. Our b is -5, so we got to square the entire -5. And we have minus 4 times our a, which is 2. So let's plug in 2 in for the a. And our c is 3, so let's plug in 3 for the c. So notice I'm just plugging in the numbers into each of the letters for a, b, and c. Now remember, all of this is going to be over 2a, where my a is 2, so it's going to be 2 times 2 at the bottom. Once I have all of this, we're just going to use our PEMDAS and just start evaluating all of this. So a -5 becomes a +5. We have a plus minus square root. Let's do the inside. -5 squared, that's going to be +25. Right, -5 times -5 is +25. Now here what I like to do is I like to keep the minus there first and just look at the numbers, right? So let's look at right here. The 4 times the 2 times the 3. 4 times 2 is 8. 8 times 3 is 24. So then this is going to give me minus 24. And then all of this is going to be over 2 times 2, which is 4. And now notice that we could kind of simplify this a bit more. Inside the square root, 25 minus 24, I know that's going to be equal to 5 plus minus square root of 1 all over 4. And then we know square root of 1, that's just equal to 1. So this will give me x is equal to 5 plus minus 1 all over 4. Now here, I just need to make sure you guys understand that this is 2 answers, right? Notice that this is a plus minus right here. So we have one answer that says 5 plus 1 over 4, and the other one that says 5 minus 1 over 4. So what I like to do here, I usually like to split up into 2 scenarios again. Again, the first one is the 5 plus 1 over 4, and then the second one would be the 5 minus 1 over 4. And then from here, you're just going to solve for each of these to find out what your answers are. So the first one, 5 plus 1 is 6 over 4. And then this is a fraction that we could simplify. They're both divisible by 2. So this would give me 3/2. The second one down here, 5 minus 1, that gives me 4. So we get 4 over 4. And that simplifies to just 1. So we found out our answers are going to be 3 over 2 and +1. And that's basically it. That's how we use the quadratic formula. You're just going to make sure your quadratic is in standard form first, find your a, b, and c, plug it into your formula, and then from that point on, you just got to make sure you use your PEMDAS correctly, and you get your answers at the end. It's pretty simple. So let's do one more example to make sure we get the hang of it. Then we'll do a u-try, and then we'll move on from there. Okay? So here's another example. Let's try this one. Let's say we had 4x squared minus 4x is equal to -1. First thing I want to do, make sure it's in standard form. Notice that it is not in standard form because I got to make sure it's equal to 0, right? So first thing I want to do, let's take this -1, move it to the other side, and we could do that by adding 1 to both sides. Now once I do that, these will cancel, and I get the 0 on the right side. Now let's just write it in standard form on the left. So we have 4x squared minus 4x plus 1 is equal to 0. And again, I know according to my standard form, which is ax squared plus bx plus c, I could see that my a is equal to 4, my b is equal to -4, and my c is equal to 1. So once you know all 3 of these things, all we're going to do, just plug into your quadratic formula, and then you should be able to get your answer. So again, this part's just algebra, right? Just making sure you know how to use your PEMDAS correctly. So I'm just going to go through this a bit more quickly just so we could check our answers, see how we do. So x equals negative b, so our b is negative 4, plus minus square root, our b is negative 4, so we have negative 4 squared, minus 4 times a times c, which is 4 and 1 respectively. And all of this is divided by 2a. Again, my a is 4. Once we plug all of those in, all we're going to do now is just evaluate it. So this is going to give us negative 4 is a positive 4, plus minus square root. Negative 4 squared, that gives me 16. All of this right here, remember what I like to do? I like to keep this minus sign here first, so just keep that exactly the same. And now let's do this part. The 4 times 4 times 1. 4 times 4 is 16. 16 times 1 is still 16, so we get 16 minus 16 all over 2 times 4, which is 8. Notice 16 minus 16 gives us 0, so this just becomes x equals 4 plus minus. This is going to give us a square root of 0, which is basically 0, so we're just going to keep that as 0 all over 8. And technically, we don't even need that 0, right? Because if you're just adding or subtracting a 0, it's just the number 4, right? So we could technically just rewrite this as, I'll show all the steps all the way. So just to show you how it looks like, right? So we would get something like this, but we know the square root of 0 is just 0. So this would give me 4 plus minus 0 over 8. But adding or subtracting a 0 doesn't really do anything, so this is just going to give us 4 over 8. And then we could simplify that, so our answer would just be 1/2. So again, it should be pretty simple as long as you know what your letters are from your quadratic formula. From your quadratic and standard form, and you'll just plug into your quadratic formula, and you should be able to get your answer from that. Okay, so with that said, here's a u-try for us to do over here. We'll go ahead and try this one out here on the side. Remember, make sure it's in standard form first. Write down the standard form so you know what your a, b, and c are, and then go ahead and use that quadratic formula to find your solutions. So go ahead and try it out. All right, so if you guys tried it out, again, the process is pretty much the same, so I'm just going to go through it really quickly. First thing we should do here, subtract the x to the other side, so we have this in standard form. This is going to give us 2x squared minus x minus 1 is equal to 0. And according to my standard form, which is ax squared plus bx plus c is equal to 0, I know that my a is equal to 2, my b is equal to negative 1, and my c is equal to negative 1 as well. Once I know all of those, we're just going to plug into our formula. So remember, x is equal to negative b, but our b is negative 1, plus minus square root of b squared. B is negative 1 again, so we get negative 1 squared, minus 4 times a, which is 2, times c, which is negative 1. And all of this is divided by 2 times a, which is 2. And now we're just going to simplify. Negative 1 becomes a positive 1, plus minus square root. Negative 1 squared is just 1. I'm going to keep that minus sign the same. And now let's just do this part right here. 4 times 2 times negative 1. 4 times 2 is 8. 8 times negative 1 is negative 8. So this gives us 1 minus a negative 8 here. And all of this is divided by 2 times 2, which is 4. Now notice that if I do minus a negative 8 here, that's the same as adding. So this is 1 plus 8. So this is actually going to give us 1 plus minus square root of 3. Or sorry, square root of 9. I'm getting ahead of myself here. The 1 plus 8 gives us the 9. All of this is over 4. And now we know the square root of 9 is 3. So this would give us x is equal to 1 plus minus 3 all over 4. Once you get to this step, we could go ahead and split it up to our two equations. So the first one is going to be 1 plus 3 over 4. And the second one would be 1 minus 3 over 4. Once we solve these, 1 plus 3, that gives us 4 over 4. So this is just going to be 1. The second one, 1 minus 3 gives me negative 2 over 4. And then those are both divisible by 2. So we're going to get negative 1/2 for the second one. So our answers for this one should be 1 and negative half. And I hope some of you guys got that as well. So that pretty much sums up our quadratic formula. But I want us to go back to that one problem in the beginning. Do you guys remember when I asked you to try to use the Xbox method and it wasn't working, right? So let's go ahead and go back to that problem and see what happens if we use the quadratic formula. So here's the problem we are working on. Let's say we use our quadratic formula. So notice that this is our ax squared plus bx plus c. We know that our a is 1, our b is negative 5, and our c is 3. I'm going to speed run this because I just want to show you what kind of answer we get. Because so far we've been getting nice numbers, but sometimes it's possible you won't get nice numbers. For example, let's say we did this one. So we have negative b plus minus the square root of b squared minus 4 times a times c all over 2 times a. Notice that this is going to give us positive 5 plus minus square root negative 5 squared is 25. We have the minus sign. 4 times 1 is 4. 4 times 3 is 12. So we get 12, and the 2 times 1 is 2. And if I do 25 minus 12, that gives us 13. So this gives us x is equal to 5 plus minus square root of 13 all over 2. And notice that this time our square root of 13, it doesn't give us a nice number, right? And this is what I wanted to show you, that sometimes your square roots aren't going to be perfect squares, and you're just going to end up with an answer just like this. And I know it looks kind of weird, but technically this is the simplest form, right? There's nothing else we could really do to this, so our answer would be the solution right here. Just keep in mind that you realize that this is 2 solutions, right? Because we got that plus and minus here. So just make sure you understand that this is 2 solutions. Technically, the first solution is the 5 plus square root of 13 over 2, and the other one is 5 minus square root of 13 over 2. So just understand that this is 2 different solutions. One more thing I want to mention, pretend this square root of 13, if that was something like square root of 20, you're able to simplify square root of 20 more, right? We know that square root of 20 is the same as square root of 4 times square root of 5, and we know we could write this as 2 square root of 5, right? So if you're able to simplify the square root more, just make sure to do that as well. So just make sure you're always on the lookout for things that can be simplified at the end. So that basically covers our quadratic formula. Now there's one more thing we want to cover that's part of the quadratic formula, and that's going to be called the discriminant. So we'll quickly go through what the discriminant is, do some problems with that, and we'll be done with the lesson. Okay, so let's go back to where we were. So this was the u-try that we just did, and now let's talk about the discriminant. So what the discriminant is, it's a value that you find that helps you figure out how many solutions a quadratic would have. So I'll explain what I mean by showing you the definition and just kind of showing you some diagrams. So the discriminant, let's call it the variable d. This is an expression that helps you determine the number and the types of solutions of a quadratic equation. Technically, this also helps you figure out how many x-intercepts there are for a parabola, right, when you graph the quadratic, but they kind of go hand in hand. So we're going to see what this discriminant does. Okay, now your discriminant is, again, our discriminant's d, but what it's equal to is this one, b squared minus 4ac. And that should look very familiar because it's actually part of your quadratic formula. If you notice this b squared minus 4ac, if I go back to our second slide here, notice that the quadratic formula right here, inside that square root, the b squared minus 4ac, that is your discriminant, right? So that's where your discriminant comes from. It's whatever's inside of the square root. But the discriminant is nice because depending on what that's equal to, it's going to tell you how many solutions and what kind of solutions a quadratic will have, and also how many x-intercepts it will have. So how do I know? Well, if your discriminant is positive, right? So let's say you did b squared minus 4ac, comes out to a positive number, then you're actually going to have two real solutions. And that means if you graph it, you're going to have two x-intercepts. Your parabola is going to cross the x-axis 2 times. If your discriminant is 0, then that's going to be one real solution, which means that if you graph the quadratic, right, the parabola, it's only going to cross the x-axis once, as you could see in this diagram here. Lastly, if your discriminant is negative, then you have no real solution. And if you end up graphing this parabola, it's not crossing the x-axis at all. There's going to be no x-intercepts. So the discriminant is very powerful. It helps us find how many solutions, how many x-intercepts a quadratic would have. And again, it's a very simple calculation, right? You're just doing b squared minus 4ac. So just make sure, again, your quadratic is in standard form. Find your discriminant, and it's going to give you a lot of valuable information. So let's put it to the test on the next slide. I want us to find the discriminant so that we could determine the number of real solutions. So, for example, let's say we had this quadratic equation here. Let's find the discriminant to determine the number of real solutions. So again, what I would do first, let's write down the quadratic in standard form, which is ax squared plus bx plus c is equal to 0. And now we could see that our a is 1, right? There's an invisible 1 in front. Our b is going to be 8, and our c is negative 3. And now once we know these, let's just plug it in our discriminant, see if it's positive, 0, or negative, and that's going to tell us how many real solutions we have. Okay, so the discriminant, again, was d, and that's equal to b squared minus 4ac. My b is 8, so we get 8 squared, minus 4ac, my a is 1, and my c is negative 3. So we're just going to calculate this, see whether it's positive, 0, or negative, and then we could see how many solutions it will have. So 8 squared is 64. I'm going to keep that minus sign there and just do this part first. 4 times 1 times negative 3. 4 times 1 is 4. 4 times negative 3 is negative 12. So this will give me 64 minus a negative 12. If we calculate that, this is going to give us our discriminant is going to be equal to, if I subtract a negative, that's the same thing as adding. So this is basically 64 plus 12, which gives us 76. Now I notice this number is positive. So what does that mean? Well, if I go back, if our discriminant is positive, how many real solutions do we have? We're going to have 2 real solutions. So all we're going to say here is we have 2 real solutions. Easy as that. So go ahead and try out these next 2. Use the discriminant to figure out how many solutions these quadratics will have, and then we'll check our answers together afterwards. Alrighty, let's go ahead and see how we did. So again, make sure that it's in standard form first. So we're going to subtract the 6x to the other side first. Once we do that, we should end up with 9x squared minus 6x plus 1 is equal to 0. And then from here, we're going to write our standard form so we could see what our a, b, and c are, which in this case, our a is equal to 9, our b is equal to negative 6, and our c is equal to 1. We're going to plug all of those in our discriminant. Remember, it's b squared minus 4ac. So b, which is negative 6, right? So b squared minus 4 times my a, which is 9, times my c, which is 1. And then if we just calculate this, negative 6 squared is 36. We have a minus sign here. 4 times 9 is 36. 36 times 1 is 36. So we get 36 minus 36, which actually gives me 0. And if we go back to the previous slides, if our discriminant is 0, we know we have 1 real solution. So for this one, let's write we have 1 real solution. All right, last one. We have 6x squared plus 2x equals negative 1. Same thing. Let's put it in standard form first. by adding 1 to the other side. This is going to give me 6x squared plus 2x plus 1 is equal to 0. From here, notice our standard form is ax squared plus bx plus c. So I know my a is equal to 6, my b is equal to 2, my c is equal to 1. I'm going to plug all of those into my discriminant. Remember, again, that is b squared, so my b is 2, so it's 2 squared, minus 4 times my a, which is 6, times my c, which is 1. And now we're going to combine all of these together. 2 squared is 4. Going to keep the minus sign there. Let's do this part right here. 4 times 6 times 1. 4 times 6 is 24. 24 times 1 is 24 still. So we get 4 minus 24. This ends up giving me 4 minus 24 is negative 20. So now my discriminant is negative. And again, according to our last slide, if your discriminant is negative, we have no real solutions. So for this one, let's write no real solutions. So hopefully you guys got that as well. That's how we use the discriminant to determine how many solutions quadratics would have. Now we're also going to do it for, if you guys notice here that it says for x-intercepts as well, right? 2x-intercepts, 1x-intercept, or no x-intercepts. It's pretty much the same process. So we'll kind of do just, I think I had 2 u-tries, but we'll just do one of them just to save ourselves some time, okay? So let's try this one very quickly as an example. We'll do 1 u-try. Then I think I got one more bonus slide. Yeah, and then we'll be done. So lots of stuff today, but it's jam-packed. But let's go ahead and try this one out. So same thing, but notice this time that I gave you an equation, right? Y is equal to 2x squared plus 3x plus 9. And we're going to find the discriminant to determine how many x-intercepts the graph will have. So same thing, right? We're going to find the standard form. So we know what our A, B, and C are, which in this case are 3. Sorry, our A is 2 actually. Our B is 3. And our C is 9. So we're going to plug that into our discriminant again. So our discriminant is b squared, which in this case is 3 squared, minus 4 times my a, which is 2, times my c, which is 9. And now I'm just going to evaluate this. 3 squared is 9. I keep the minus sign there. Let's do the 4 times 2 times 9. 4 times 2 is 8. 8 times 9 is 72. So we get 9 minus 72. Could do that in your head, or you could plug in your calculator. I believe this is going to give you negative 63, right? 2, 3, 4, 5, 6, 7, 8, 9, yes, negative 63. So from here, I know my discriminant is negative. And again, now this time we're just looking at the x-intercepts. It's pretty much the same thing, right? Oh wait, our discriminant was negative. So that means we're going to have no x-intercepts. So for this one, we're going to write no x-intercepts. So pretty much the same process, right? I think it's pretty easy if you knew how to do the last slide especially. So again, just to save ourselves some time, we'll just do 1 u-try. Let's go ahead and try the first one. So let's not do this one. Let's try this first one. And again, this one looks a little different, but we did cover this in the previous slide. I'll just give you a little hint before we get started. This part right here, if a term is missing, then use 0. I'll just leave it at that. But that's going to be my little hint on how you're going to be solving this current problem. Okay, so again, here's the u-try. I want you to try this one right here. Go ahead and try it out, and we'll check our answers together. All right, so for this one, notice that our standard form, ax squared plus bx plus c. Notice the c is missing. So again, if there's a term missing, we're going to use 0. Our a and b though, my a I have an invisible 1. My b I have an invisible negative 1. And then the c is going to be 0. So that's our a, b, and c. Plug it into our discriminant. We get b squared minus 4 times a times c, which is 0. And now when I evaluate all of these, negative 1 squared is 1. I get the minus sign. 4 times 1 is 4. 4 times 0 is 0. So I get 0. And 1 minus 0 is just 1. Notice our discriminant is positive. If I go back a few slides, if our discriminant is positive, we end up with 2 x-intercepts. So for this one, we're going to say our answer is 2 x-intercepts. And that's it for this one. Alrighty, one last slide. This one's going to be short. I just want to show you what could happen. This is a possible scenario that could happen when you're just trying to solve a quadratic using the quadratic formula. So let's say we had an equation like this one. I actually want you guys to try it out, and I want you guys to see what's going to happen. And then once you get to your answer, just check with mine to see what we get. Okay, so go ahead and try it out first, and then I'll show you why this one would be a little bit special. All right, so for this one, we have x squared plus 7x equals negative 16. Again, if I ask you to solve it using the quadratic formula, we'll add 16 to the other side so that we could put it in standard form. And then once we put it in standard form, we could find our a, b, and c's so that we could plug it into our quadratic formula. So in this case, our a is 1, our b is 7, and our c is 16. Now, when you plug it into your quadratic formula, again, b squared plus minus, sorry, it's not b squared. What am I doing? Negative b. So negative b is negative 7 plus minus square root. This is where your b squared is. B squared, which is 7 squared, minus 4 times your a, which is 1, times your c, which is 16. And all of this is over 2 times a, which is 1. If we simplify this and evaluate it, we have a negative 7 on the outside still. On the inside, though, 7 squared, that gives me 49. I have a minus sign, and then I have this part right here, 4 times 1 times 16. 4 times 1 is 4. 4 times 16 is 64. And all of this is divided by 2 times 1, which is 2. Now, this is the part I want you to understand. Right here, when we have the square root of 49 minus 64, if you actually calculate that, this gives us a negative number. It gives us specifically negative 15. And I need you to understand this part. Do you guys remember, technically, all of this, right, the negative 15, wasn't that our discriminant, right? Because the b squared minus 4ac, that's our discriminant. Remember, all of this was inside the square root, right? And we found out that if your discriminant, in this case, which is negative 15, if your discriminant is negative, then you end up with no real solutions. So if we have a problem like this where we end up with a negative in the square root, we don't box this as our answer, because this is technically not a real solution. So what we should write instead, again, if I see that our discriminant is negative, then we're going to say our answer is actually no real solutions. So just keep that in mind, that when you do some of these problems, it's possible that your discriminant is going to be negative in your quadratic formula. And again, if you catch that, you got to make sure you write no real solution. All right. With that said, I believe that concludes our video. So here are your homework problems for today's lesson. Some of the instructions ask you to round your answers. I don't want you to do that. I want you to do it just like how we did. Like for example, if you get square root of, like, I don't know, 23, just keep it as square root of 23, right? Don't plug it in your calculator or find a decimal. Don't do that. I just want you to keep it as whatever answer it's going to be in the square root form. Okay. So hope you guys enjoyed this video. If you have any questions, just make sure you save it for the next time I see you all, and I'll try to answer any questions or clarifications that you all have for today's lesson. But besides that, thank you guys so much for watching the video. Hope you guys enjoy the rest of your day, and I'll see you next time.